So, well, I thought we had a pretty good case for entanglement. So now we have to tackle the question of shielding. So, here's the shield. That's a double-walled UPS, uninterruptible power supply. So it's a double-walled steel gauge, which is pretty darn good. To set up a control, we put the unit in there. Obviously, we stick a chip in there, initialize, check, and see what the changes are. And after 2 days, well, there's no partner, nothing else is on, so we want to control. And we find 2 changes in the unit over 2 days, so 1 per day. Now, this is where it's cool. So then, we have the unit in its cage. We have my personal box, which is this, because I wanted to generate some energy. And then we have the real-time analyzer monitoring the situation between the two. 2 results. Within the cage, the unit under test, which formerly only exhibited 1 change per day with no partner, is now showing us over 2 days 8 changes per day. So it's getting energy through the shielding that it did not get before. That's astounding. What's also fairly astounding is that many, well, to be specific, 5 addresses were independently identified by the analyzer, which means that it's entangled register specific as well. Now, for a better view of this, well, here's a data summary. Let me add this up. So here we have 17 changes in the unit under test. In column 2, we have the address at which those changes occurred. In column 3, we have the changed data. In here, I convert it to binary. When you convert it to binary, you get the number of bits that have been actually changed. So we add those up. You can call that a checksum if you like. And you get a value from 1 to 8, which indicates the depth to which that register was changed. That's for the unit under test. Now for the real-time analyzer, it's doing something else. It's identifying addresses, these, and telling you how many changes occurred on a 1-hour sampling basis, this again over 2 days. So the bars in green show the common addresses between the UUT and the RTA. That's 30% of the 17, a third of the 17 changes, let's say. But look at the histogram. Obviously, there's much more going on here than just 5 common addresses. What we're seeing here is nothing other than you can only describe as a resonance between devices. And you have to remember, these are 2 separate devices operating in 2 completely different manners. One's operating static, and one's operating dynamic in real time. So we have a very interesting correlation here. This is history making, I suggest. Now, before I suggest that, actually, let me back off a bit. There are only 6 demonstrations, I realize that, okay? They've been well guided. But as I mentioned before, there's a difference between correlation and causality. When you have established sciences, you can go to an expert and ask what the threshold is. We don't really have that here. So I want to address one objection, and that is gate charge coupling. As I mentioned, the signature archive is essentially random. So that fed my decision to use Fs and zeros to achieve these high contrasts. In early DRAM, particularly capacitive-based DRAM, there was a phenomenon known as gate charge coupling, where a bit might get too much energy on it, and it would pull adjacent bits in the same direction, so that you could flip a bit and it might flip 3 or 4 at the same time. If gate charge coupling is a factor, then my using Fs and zeros would have fed right into that. Gate charge coupling is a reasonable objection, but my reasonable answer is that if it were a factor, it would have shown up already in the signature archive. Instead of having random events in the signature archive, I would have only seen Fs and zeros on an 80% basis. So that's my answer to gate charge coupling, but the ultimate answer really lies with semiconductor experts. So, do we know what we're measuring? This has taken a lot of thought. I used to only be able to explain it in terms of Dr. Tiller's theories, and now I think he's made a mistake. With all due respect. And I do mean that. After all, I was brought in to straighten out Dr. Tiller's electronics. So in reviewing the situation, I found this paragraph. Tiller had this problem with entanglement. And there's this very interesting thing, which I'll just have to quote. We placed it in the switched off state to see if they were truly isolated. Conversion. At first I was horrified because the information sealing step was not working. We were losing our control. We wouldn't be able to do careful experiments. Then I paused and realized that such an information transfer process could not have occurred via electromagnetic photons because the two devices were electrically switched off. There was no electrical power source to drive such an EM photon exchange process. However, such an information exchange process had occurred. Therefore, we had discovered the existence of some other unknown type of information communication system than electromagnetism. Wow! And he repeats it over here. I'm sorry, he's wrong. I'll show you why. And the reason I have to show you why is because what has caused Dr. Tiller's work to be rejected is because on the basis of this observation, he jumped into concluding that there must be three unaccepted things, three things which are not accepted by modern physics. One is a domain of reciprocal magnetism, which is the Alice in Wonderland of our existing electromagnetic spectrum. The second is deltrons, which are particles that travel faster than the speed of light. And the third is magnetic monopoles, which are single charge magnetic particles, and that means you have a magnet that doesn't have polarity, north and south. None of those concepts are accepted by modern science, and so people just reject Dr. Tiller's stuff out of hand. I think there's a way to recover some of his work.